and action.
Oh hey, I didn't see you there. Today we're going to be talking about black holes. What I meant was, today we're going to be talking about black holes. Yeah, black holes. As we know, black holes are the result of suns that have imploded on their mass. This happens when the energy from the nuclear fission in the core of the sun can no longer sustain its gravity. When this happens, the sun collapses into a black hole! Now, black holes don't last forever. They eventually dissipate or evaporate, and here's how.
In space, there are virtual particles popping in and out of existence in pairs of matter and antimatter particles. They pop in, crash into each other, and disappear in a small explosion of energy. However, when this happens near a black hole, one particle gets sucked into the black hole, while the other particle escapes the black hole, along with a small percentage of the black hole's mass.
And voila, we have ourselves a shrinking black hole. And this is called Hawkings Radiation. Now, to clarify a few things. 1. Virtual particles come from the field of particles all around us. This could be an electron's field or a photon's field or a neutrino's field. They form when there's more energy or stuff in a particular location in the field, like a knot in a string. 2. It takes a black hole a very long time to irradiate fully. For example, a black hole the mass of our sun would take 10 to the 67th power years to fully disappear. To help put this into perspective, imagine you were a metaphoric black hole and every 100 years an atom would get taken away. So, when you're born, one atom will get taken away, and in the next 100 years, another atom will get taken away. By the time you run out of atoms to lose, the last of the suns will be gone, and the whole human race would be extinct. Wow, that's a bit dark. Get it? Because there'll be no suns. Now here's the problem. In the universe, there's something called information. This is basically a description for the blueprint for stuff. For example, on a much simpler scale, there's diamond and graphite. Both are made of carbon, which is their blueprint, but their information is what makes them different. In this case, the information could be the structure of the carbon element. For diamond, the carbon is in a closed shape, while for graphite, it's more in a stacking order. Okay, now here's the actual problem. Information like matter or mass cannot be created or destroyed, simply transformed. However, although scientists have been unable to find the information that entered the black hole and the particles that escaped the black hole, which naturally begs the quandary, where does all that information go? This is called the information paradox. There are a few theories as to where this information goes, one being that it gets transported to a different space, inside or outside the universe, who knows. The other being that it gets altered into something else that we can't recognize yet. Now, and I guess you could say this is all information waiting to be discovered. Question is, by who? Will it be you? Nah, I call dibs.
Finally done with that. Let's get some kitkats. Wait a minute, is this thing still on?